Hello students, in the previous class we discussed the problems related to the ellipse which is in the standard form, that is x square by a square plus y square by b square is equal to 1 for both cases a greater than b and a less than b. Today also we are going to discuss some of the objective problems related to the ellipse which is in the standard form also. Here we discuss the concepts, that is the focal distance of any point on the ellipse first of all, and we have to find out the maximum area of the rectangle that is inscribed in the ellipse which is in the standard form, that is x square by a square plus y square by b square equal to 1 is what, and we will do some of the problems related to that ellipse which is in the standard form or 4 standard forms. Let us do one by one problem. Be careful, listen carefully my dears. This is the result. Maximum area of the rectangle inscribed in an ellipse x square by a square plus y square by b square equal to 1 is 2ab, and length of the sides are root 2a and root 2b. This is your question. How to do this one? Maximum area of the rectangle you have to find out, that is inscribed in your ellipse x square by a square plus y square by b square equal to 1. So this is the standard form. For my sake of convenience you take a greater than b. So let us try to draw the figure first of all. This is x-axis, this is y-axis. So your major axis along x-axis, minor axis along y-axis. This is your ellipse. X square by a square plus y square by b square is equal to 1. Now we have to find out the maximum area of the rectangle that is inscribed in the ellipse. See here, this is the rectangle which is inscribed in the ellipse. We have to find out its maximum area. You can insert infinite number of rectangles in that ellipse, but we have to find out the maximum area of the rectangle that is inscribed in the ellipse. Suppose its vertex, one of the vertex of rectangle is P say. Its coordinates are P a cos theta comma B sin theta. So I am taking coordinates of P as a cos theta comma B sin theta. These are the coordinates of P. So what is the distance from here to here? This is a cos theta. This is what? B sin theta. By the definition of the coordinate system itself, a cos theta, b sin theta are there. The curve is symmetric over both x and y axis. The distance from here to here is also a cos theta. Again the distance from here to here is b sin theta. Now this is Q say R S. PQRS is your rectangle. Area of the rectangle is equals to PS into PQ. Am I correct? What is the distance PS? A cos theta plus a cos theta, that is 2a cos theta into 2b sin theta. So 2ab into 2 sin theta cos theta. It is nothing but sin 2 theta. So area A is equals to 2ab sin 2 theta. It is maximum when sin 2 theta is 1, because the range of sin 2 theta or sin theta is minus 1 to 1. For sin 2 theta equal to 1, we obtain A maximum. A maximum is equals to 2ab into 1 for sin 2 theta is equals to 1. Sin 2 theta equal to 1 means 2 theta is equals to pi by 2, implies theta is equals to pi by 4. So maximum area is 2ab we obtained. At that time we have to find out the length of the sides. What are the lengths of sides? 2a cos theta, 2b sin theta. At theta equal to pi by 4, at theta equal to pi by 4, 2a cos theta is equals to 2a cos cos pi by 4. That is 1 by root 2, root 2a. This is root 2a. 2a sin pi by 4. This is also root 2b. 2b sin pi by 4. Root 2b. These are the sine terms. One is root 2a, other one is root 2b. Its length is root 2a and its length is root 2b. The area is 2ab. So it is very simple question just by using the parametric equations of the ellipse. So this is any point on the ellipse which is one of the vertex of your rectangle. Understand? So maximum area that can be inscribed in an ellipse is 2ab. At that time the lengths of the sides of the rectangle are what? Root 2a, root 2b. Okay. Let us see the next question or next concept. B is 1.5 minor axis. S and S dash are foci of the ellipse. And B S dash S is equals to theta, then eccentricity E is equals to cos theta. Okay. B is 1.5 minor axis. S and S dash are foci of the ellipse. Angle B S dash S is theta. Then we have to show that the eccentricity of the ellipse is what? Cos theta. What is B? 1.5 the minor axis of an ellipse. What are S and S dash? Foci of the ellipse. Let us try to draw the figure for this concept. This is x-axis. This is y-axis. Your major axis along x-axis, minor axis along y-axis. It is your ellipse. X square by a square plus y square by b square is equals to 1 for a greater than b set. X square by a square plus y square by b square is equals to 1. You take a greater than b. Now, these are foci. One is S and other one is S dash. What is B? 1.5 the minor axis. This is 1.5 the minor axis. Understand? Now, join S dash B. This is S dash B. Its angle is given to you. That is theta. Now, we have to show that E is equals to cos theta. Eccentricity of the ellipse is cos theta. All of you know that this is center of the ellipse. We have CS is equal to CS dash. CS is equal to CS dash is equal to AE. So the distance from here to here is AE. Once if you find the distance, you can easily find cos theta. Am I correct or not? Now S dash B. S dash B means what? Focal distance of point B. What are the coordinates of B minus 0, B? What are the coordinates of S dash minus AE, 0? So S dash B can you find or not? This is nothing but square root of AE minus 0 whole square plus 0 minus B whole square. That is B square. It is nothing but root of A square E square plus B square. But what is your B square? A square E square plus A square minus A square E square. A square into 1 minus E square is your B square. So A square E square, A square E square gets cancelled. That is your A. So don't forget, my dears, the focal distance of end of minor axis is always equal to semi-major axis. Semi-major axis. So the distance from here to here is what? A units. Therefore, you have this is AE and this is A units. You can easily write cos theta by adjacent side by hypotenuse. From the right angle triangle S dash CB, cos theta is equals to AE by A. AE gets cancelled, we have E. Therefore, eccentricity of the ellipse is cos theta. For any problem, if you have this angle, you can write immediately eccentricity as cos theta. What is that angle? B S dash S. If angle B S dash S is equals to theta, immediately we can write the eccentricity as cos theta. This is the focal distance. So just we are applying a 2-point form. formula, distance between the 2 points. Or you may write S dash P is equals to BM also. SP is equals to E into PM. So the distance from 0 comma B to directrix into E times, that is also gives SB. Okay, focal distance of point. You can find the focal distance of any point on the ellipse also. This is the thing here, E is equal to cos theta. Let us try to find the focal distance of any point on the ellipse now. Suppose this is any point. This is any point P on the ellipse. If you want to find this focal distance, or you may find the focal distance. So SP is equals to what? SP is equal to E into PM. PM is nothing but perpendicular distance from P to your directrix. Suppose this is your directrix, this is PM. Perpendicular distance. What is the directrix equation? X equal to A by E. So Ex minus A equal to 0. Always A is positive. You may take A minus Ex is equals to 0 is the equation of the directrix. So can I find the perpendicular distance from any point P x1 comma y1 to the directrix or not? Yes. That is equals to E times of modulus of A minus Ex1 A minus Ex1 by root of A square plus B square. That is here E square is only there. There is no y coefficient is 0, so we have E square plus 0. So moduli gets cancelled, that is modulus of A minus Ex1. A is always more than Ex1, so you take A minus Ex1 is focal distance, SP. Similarly, you can show that S dash P is equal to A plus Ex1. These are the two focal distances of any point on the ellipse. So what is the formula, my dears? A minus Ex1 or plus A plus or minus Ex1 are the focal distances of any point on your ellipse. So if you consider your point P as B, at that time you have the coordinates of 0 comma B. This is your x1, this is your y1. What is the formula? A minus r plus Ex1. E into what is your x1? 0. So we have A. In this manner also we can show that the distance from here to here is A units. Don't forget these formulas. These are the focal distances of any point on the ellipse. For A greater than B. This is the formula for A greater than B. What are they? A plus or minus Ex1. For A less than B, focal distances are B plus or minus Ey1. B plus or minus Ey1. So we have focal distances A plus or minus Ex1 and B plus or minus Ey1 are the focal distances of any point Px1, y1 on the ellipse. For this is A greater than B, for A less than B. These are the two formulae. Suppose your point is in the parametric form. What is x1? A cos theta. So A plus or minus E times of A cos theta is the focal distance of P of theta. We need A into 1 plus or minus E cos theta. A into 1 plus or minus E cos theta, or for A less than B, we have B into 1 plus or minus E sin theta. By depending upon situation, you have to use these four formulae which are related to focal distance of point on the ellipse. So A plus or minus Ex1, B plus or minus Ey1. Replace x1 by A cos theta and y1 by B sin theta. We have done another two forms of the focal distances of any point. Understand? So these are the formulas related to the focal distance of any point on the ellipse. So from that also we can show that the distance S dash B as A units. After that you can apply the cos theta. You get E is equals to cos theta. You get E is equals to cos theta. Understand? So in this problem we can find the maximum distance from the focus to any point on the ellipse. Suppose P is the variable point which moves on the ellipse. we can find the maximum distances and minimum distance of SP. Your P is here, you get minimum. Your P is here, you get maximum distance. So the vertices are maximum and minimum distances from focus to the point on the ellipse. Your point is ends of the major axis. So SA is the shortest distance, focal distance, and SA dash is the longest focal distance of your point. That is, you have what are the coordinates of this point? A comma 0. This is x1, this is y1. Here minus a comma 0. So this is x1, this is y1 at that time. What is the focal distance formula? A plus ex1 say. A plus ex1. For x1 is equals to minus a, what we have? A minus ex1. For plus, what we have? A plus ex1. x1 is what? A. You take. If you take a, here minus a. Minus into minus plus. So a minus e into a, that is a into 1 minus e and a into 1 plus e are the shortest and longest distances from focus to point on the ellipse. So shortest focal distance is what? A into 1 minus e. Farthest focal distance is what? A into 1 plus e. A into 1 plus e is maximum focal distance of point on the ellipse. A into 1 minus e is shortest focal distance of point on the ellipse. So maximum and minimum, the ratio is what? 1 plus e is to 1 minus e. 1 plus e is to 1 minus e. Don't forget, this is the concept, entire concept related to the focal distance of point on the ellipse. Understand, my dears? Now, with the help of these concepts, let us do some of the problems related to these concepts. Yeah. You have to find out the center of the ellipse. This is general equation of ellipse. It is not in the standard form. You have xy term also. So, some second degree equation ax square plus 2hxy ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents an ellipse if delta should not be equal to 0 and your h square less than ab. H square less than ab. What is h value? Minus 1. H square is what? 1. A into b is 49. A into b is equal to 49. Clearly h square less than ab and you can write delta value. What is delta value? ABC plus 2fgh minus af square minus bg square minus ch square is equal to 0. You can find this delta value. That constant should be not equal to 0. So at that time that represents ellipse. If delta is equal to 0, that represents pair of lines. Understand? All of you know in your first year syllabus. This is your ellipse. You have to find out the center of the ellipse. For that, you do one thing. Partial derivative with respect to x and partial derivative with respect to y. You get two equations. By solving those equations itself, we get the center of the ellipse. Don't say that those equations are axis. They are not axis, but their point of intersection gives your center of the ellipse. Okay, 7x square minus 2xy plus 7y square minus 34x plus 14y plus 38 is equals to 0. So, partial derivative with respect to x, what we have done? 14x minus 2y. We are doing partial derivative with respect to x minus 34 equal to 0. Implies 7x minus y minus 17 is equal to 0. This is one equation. And partial derivative with respect to y. We get this becomes 0 with respect to y. The derivative of y is 1 minus 2x. You treat x as constant when you are doing partial derivative with respect to y. We treat y as constant when we are doing partial derivative with respect to x. So this is minus 2x plus 14y, and again we have plus 14 is equals to 0. Derivative of pure constant is always 0. So 14 into y is there also. Derivative of y is 1 with respect to y. So we have this one. X minus 2y, x minus 7y minus 7 equal to 0. By solving these two equations itself, we get the center of the ellipse. So for that, I am multiplying this by 7. We have 7x minus 49y minus 49 equal to 0. This is a equation number 1. This is a equation number 2. 1 minus 2. What happened? 7x gets cancelled. This is 48y. Now minus 17 plus 49. So this is 32. Minus 32. Minus or plus? This is plus 32. 32 equal to 0. So the y value is equals to minus 32 by 48. 16 2s, 16 3s. That is, the y coordinate is minus 2 by 3. Substitute in any of the equations, we get y value also, x value also. Substitute here x minus of minus plus 7 into 2, 14 by 3. X plus 14 by 3 minus 7 is equals to 0. So the value of x is 7 minus 14 by 3. This is 21 minus 14 by 3. It is nothing but 7 by 3. So what are the coordinates of center? 7 by 3 comma minus 2 by 3. These are the coordinates of the center of the ellipse. So by doing partial derivative with respect to x, we get one axis, and partial derivative with respect to y, we get another axis. We can't say which one is major axis, which one is the minor axis. Just by observation, we have to do that one. Now, by solving the axis, we obtain the center of the ellipse. So the center is 7 by 3 comma minus 2 by 3. Don't try to write in the standard form, that is x minus h whole square by a square plus y minus k whole square by b square equal to 1. We can't write in that manner because xy term is there. This is general equation of the ellipse. Understand? So partial derivative with respect to x, partial derivative with respect to y, and solving these equations, we get center of the ellipse. This is the way. Okay, next problem. If the lattice rectum of the ellipse is x square tan square alpha plus y square secant square alpha equal to 1, t is 1 by 2. So length of the lattice rectum is given to you, that is half. Then you have to find out the value of alpha. So let us try to write this equation in the standard form first of all. This is nothing but x square by cot square alpha plus y square by cos square alpha is equal to 1. X square by a square plus y square by b square equal to 1 form. Which one is more, my dears? Cot square alpha is always more than cos square alpha. So we take it as a greater than b case. What is length of lattice rectum? Length of lattice rectum is equals to 2b square by a. 2 times of cos square alpha by a means cot alpha is equals to length of the lattice rectum is given as 1 by 2. This is nothing but cos square alpha by cos alpha by sin alpha. Sin alpha comes to the numerator, that is equal to 1 by 2. 1 cos alpha gets cancelled. So we have 2 sin alpha cos alpha. Sin 2 alpha implies sin 2 alpha is equals to half. We mean 2 alpha is equals to pi by 6, 30 degrees. Sin 30 degrees is equals to 1 by 2. So clearly you can write alpha as pi by 12. So your alpha is what, my dears? Pi by 12. Very simple question. Just by equating the length of the lattice rectum to half, you get the required answer. Understand? Next one. This is the question. The equation of axis of the ellipse are what? Just we discussed it. The axes are obtained by the partial derivative with respect to x, partial derivative with respect to y. We get the axis. So suppose xy term is there is no guarantee that those partial equations are axis. But if there is no xy term in the equation, definitely there will be axis. Partial derivative with respect to x, we get one axis. Partial derivative with respect to y, we get the other axis. By solving those two axes, we get the center of the ellipse. That is common thing. For both the cases, if xy term is included or not included. But xy term is included, but the partial derivative equations may or may not be the axis to that ellipse. But if there is no xy term in the ellipse, the partial derivative equations must and should be axis of that ellipse. Understand? So by doing the partial derivative with respect to x, we have this is 8x plus 8 is equal to 0. So x plus 1 equal to 0 is the one of the axis. X plus 1 equal to 0 is one of the axis. And another one, partial derivative with respect to y. Suppose 18y, this is plus 36 is equal to 0. So here y plus 2 equal to 0. This is another axis. These are the two axes. Just by doing the partial derivative with respect to x and partial derivative with respect to y, we have the axis. Let us check whether these two are correct or not by writing the standard form itself, my dears. So what are the x terms here? Is so you can take 4 common. 4 times of x square plus 2x plus 9 times of y square plus 4y is equal to minus 4. So to get the complete square, 4 times of x square plus 2x plus 1 I am writing here. 9 times of y square plus 4y plus 4 is equal to minus 4. To get the balance, we have to write plus 4 plus 36. So 4 gets cancelled. X plus 1 whole square by 4 9s plus y plus 2 whole square by 9 4s. This is the thing. So x plus 1 equal to 0 is one axis and y plus 2 equal to 0 is the other axis. It is of the form x square by y square plus y square by b square equal to 1. A greater than b here. This is a greater than b. So your major axis parallel to x axis, that is y plus 2 equal to 0. Your equation is y plus 2 equal to 0 is major axis and x plus 1 equal to 0 is minor axis. So you get the y plus 2 equal to 0. This is x plus 1 equal to 0. Major axis is what? Y plus 2. So y plus 2 is major axis. Among these two constants, 4 and 9, these are the coefficients of x square and y square. Which one is more? 9 is more. So if you partial derivative with respect to the corresponding variable, that is why you get the major axis. So among x square and y square coefficients, which one is more here? 9 is more. The attached variable is what? Y. By doing partial derivative with respect to y, we get the major axis. This is major axis. By doing partial derivative with respect to the other coefficient, we get automatically the minor axis. So you can distinguish the which one is major axis and which one is minor axis also. So we observe all these things by doing the practice. By practice itself, we can easily catch them. So by writing the standard form itself, we get the axis equations. We are going to compare these axes to the shortcut method. So how to obtain major axis, how to obtain a minor axis, from looking the equation itself, it is better to you. Right? So partial derivative with respect to y, you get major axis. Partial derivative with respect to x, you get minor axis. Suppose if it is 9x square and it is 4y square is there, you have to do partial derivative with respect to x, you get major axis. With respect to y, you get minor axis. So this is the simple technique to write the axis of the ellipse without writing the standard form. Understand? So if you have xy term is there, you do the same manner, but the equations may or may not be axis axis of the ellipse, but their point of intersection must and should be gives you center. Suppose your equation doesn't have xy term, clearly 100% the partial derivative equations are axis of your ellipse. Understand? Next one. The distance from the foci to a point x1 comma y1 to x square by 9 plus y square by 25 equal to 1. Just we discussed what about the focal distance of point. So your point of the ellipse is what my dear? X1 comma y1. Here observe the equation of ellipse. What is that? X square by 9 plus y square by 25 is equal to 1. Is equal to 1. Is it a greater than b case or a less than b case? A square is equal to 9, b square is equal to 25, so we have a less than b case. For a less than b, what are the focal distances? B plus or minus e by 1. Just we derive the formula. B plus or minus e by 1. B, what is b here? B is equal to 5. 5 plus or minus e, eccentricity of the ellipse, that is root of 25 minus 9 by 25, that is 4 by 5. 4 by 5 times of y1 means y1. This is the general point on the ellipse. You take y1 itself. So your answer is 5 plus or minus 4 by 5 y1. These are the focal distances of point on the ellipse. Why we are getting two distances? Because there exist two foci for the ellipse. Therefore, these are the two focal distances. 5 plus or minus 4 by 5 y1. Sum of the focal distances is what? Always, my dears, that is 2a. So 5 plus 4 by 5 y1 plus 5 minus 4 by 5 y1 is what? 10. That is nothing but length of the major axis. Here b is more than a. What is the length of major axis? 2b. That is 2 5 so 10 itself. So SP plus S dash P is always equal to its length of the major axis. What is that property? That property name is focal property of the ellipse. Sum of the focal distances of any point on the ellipse is always constant. So here the focal distances are what? B plus or minus E by 1. B plus or minus E by 1. Next concept. Or next problem. This is the thing. The abscissa of the points on the ellipse. The abscissa of the points on the ellipse. X square plus 4y square minus 8x plus 8y plus 4 equal to 0 lies between what? So this is given equation of ellipse. We want to find out the abscissa of the points on the ellipse. We have to find out the range of x. Abscissa means x. Range of x on the ellipse. So to write the range of x, let us convert the equation into the standard form. Then only we can write the range of abscissa. So we write all x terms at one place. X square minus 8x plus 4y square plus 8y is equals to minus 4. So x square minus 8x plus 16 I am writing to get the complete square, plus 4 is common, y square plus 2y I am writing plus 1 here. To balance that one you have to write plus 16 and plus 4 also. So 4 gets cancelled. This is nothing but x minus 4 whole square by 16 plus y plus 1 whole square by what? 4 is equal to 1. Here also we obtain a greater than b case. A square 16, b square 4, a is 4, b is 2. So 4 greater than 2, we have a greater than b case. Now what is a square value? 16. A is equals to plus or minus 4. So our axis, parallel to x-axis with center at 4 comma minus 1. Center at 4 comma minus 1 meaning it is in the fourth quadrant. So just let us draw the rough diagram. Your center is 4 comma minus 1. Suppose this is your center. Your ellipse may be in this manner. Your axis of the ellipse is parallel to x-axis. This is your 4 comma minus 1. This is your 4 comma minus 1. A is what? Plus or minus 4. Your A is 4 units. A square is 16. So your A is equal to 4. A is always positive. A is equal to 4. That means the distance from center to the vertex is 4 units. It is also 4 units. We need 4 units left and 4 units right. So 4 plus 4 is how much? 8. That is 8 comma 0. 8 comma minus 1, sorry. This is 8 comma minus 1. Y coordinate doesn't change. And minus 4, 4 minus 1, you have to subtract 4 from the x coordinate, that is 4. 4 minus 4 is 0. That is 0 comma minus 1. We mean actually the diagram is in this manner. Understand? So it is not possible. Here that is the value 0 comma minus 1. So this is your ellipse. So your ellipse is in this manner. Right? This is the possibility. Therefore, what are the x coordinates varying? The x coordinate of the ellipse points on the ellipse varying from 0 to 8. 0 to 8. That means you just like the x coordinates of vertices. Indirectly they are asking x coordinate of the vertices of ellipse they are asking. So you write both of them, that is the range of your x coordinate. So A range, the range of A is asking that. So 0 less than or equal to x less than or equal to 8 is your answer. So 0 comma minus 1 is one vertex, 8 comma 0 is the 8 comma minus 1 is the another vertex. So the range of x coordinate is 0 comma 8. So without writing the diagram, you can easily write the vertices and take x coordinates of both vertices, that gives the range of your A. So closed 0 to 8 is your answer. Okay. Not plus or minus 4. My dears, you have the center. What is your center? 4 comma minus 1. If your center is 0, 0, range of A is plus or minus 4. But your center is not 0, 0. Here is 4 comma minus 1. So 4 units left, 4 units right. For right you have 8, for left you have 0. 0 comma 8. Understand? Okay, we will move for the next problem. This is a simple locus for you. The locus of extremities of lattice rectum of family of ellipse. Family of ellipse. B square x square plus a square y square is equals to a square b square is what? The locus of extremities of lattice rectum of family of ellipse. This is very good ellipse. It is nothing but simply x square by a square plus y square by b square is equals to 1. Y square by b square equal to 1. Locus of extremities of lattice rectum of family of ellipse. So this is one of my ellipse. This is lattice rectum. It is end of the lattice rectum. What are the coordinates of end of lattice rectum? AE comma b square by A. Since the distance from here to here is AE and length of lattice rectum is 2b square by A, its half is b square by A. You are going to find out the locus of the end of the lattice rectum. Let us say x1 comma y1. This is your x1 comma y1. What is x1 y1? x1 comma y1 is equal to AE comma b square by A. AE comma b square by B. So what is x1? x1 is AE, y1 is b square by A. From options itself, which one is not there? X square is there, AY. There is no x term here. So is there any eccentricity? There is no eccentricity also. So we have to write the locus of x1 y1. So I am squaring this one. There is no e here in the options. So we are going to eliminate e. For that I am squaring on both sides. x1 square equal to a square e square. So x1 square is a square e square. You have to write b square by a square as for 1 minus e square. So b square by a square into a you can write as y1. B square by a square is nothing but 1 minus e square into a is equals to y1. So x1 square is equals to a square into e square. You can square in this one also. Y1 square is equal to b power 4 by a square is there. So your answers are in relation between a square, b square is there. B square is also there in your options. Y square is not there. So you have to eliminate. Which one is better to you? E you have to eliminate. So instead of E you can write a square into a square minus b square by a square. A square gets cancelled. X1 square is equals to a square minus b square. So we have the b square value. B square is nothing but what? A by 1. X1 square is equals to a square minus what is your b square? A by 1. Yeah, correct. So x square plus ay, x square plus ay is equal to a square is your locus. Therefore, locus of x1 y1 is x square plus ay is equal to a square. So we are eliminating e. We can use all these formulas. It is not much effect for you. So from these equations itself you have to eliminate e square. Your e square is nothing but a square minus b square by a square. A square gets cancelled. You know that a square is a square minus b square. Well-known formula. Instead of b square you just write a by 1. You get the answer. X1 square is equal to a square minus what is that? A by 1. So your locus is x square plus ay is equals to a square. So this is the locus of the extremity of the lattice rectum of ellipse. So what are the ends of the lattice rectum of ellipse? AE comma b square by a. Okay. Next one. The eccentric angles of extremities of lattice rectum of ellipse x square by a square plus y square by b square equal to 1 are given by dash. We have to find out the eccentric angles of extremities of lattice rectum of ellipse. All of you know the definition of the eccentric angle. If P is a cos theta comma b sin theta, what is that theta? Eccentric angle of that point. What is the main definition of the eccentric angle? P is any point on the ellipse. Produce Pn, that is ordinate, drawn from P to the axis, and produce NP up to Q where it meets the auxiliary circle. Join Q to center of the ellipse, you get some line. If that line makes an angle theta with major axis, that is x-axis in the positive direction, that theta is called eccentric angle of your point. So, if your point is a cos theta comma b sin theta, the eccentric angle of that point itself theta. So, what are the ends of lattice rectum? Just we discussed AE comma b square by a. It is in the first quadrant. Let us see the first quadrant. First of all, AE comma b square by a is equals to a cos theta comma b sin theta. Suppose theta is the eccentric angle of that point. When theta is eccentric angle of that point, immediately you take that point as a cos theta comma b sin theta. From that you can easily find theta. A cos theta is equals to AE. So A gets cancelled. You have cos theta is equals to E. B square by A square is equals to B square by A equals to B sin theta. You can cancel out B. So sin theta is equals to B by A. You have sin theta equal to B by A. Cos theta is equals to E. So tan theta is equals to what? Tan theta is equals to B by A by E. So B by AE is there. B by AE. Tan theta is B by AE. For 4 quadrants plus or minus B by AE we have. Therefore, the eccentric angles of 4 types of lattice rectum are theta is equals to tan inverse of plus or minus B by AE. These are the eccentric angles of the four extremities of the ends of lattice rectum. Because we have two lattice rectum, there exist four extremities. These are the four extremities of lattice rectum. Their corresponding eccentric angles are like that. Tan inverse of plus or minus B by AE. Okay. Next one. This is the question. What is that? P is a point on the ellipse of eccentricity E. So P is the point which is on the ellipse and the eccentricity of the ellipse is E. A comma A dash are vertices, S comma S dash are foci. Then the ratio of the areas of triangles P, SP, S dash and triangle AP, A dash. So P is what? Any point on the ellipse having eccentricity E. So we consider the ellipse whose equation is x square by a square plus y square by b square is equal to 1, a greater than b say. Its vertices are what? A dash. Its foci are what? SS dash. P is what? Any point on the ellipse. Then we have to find out the ratio of the two triangles, areas of the two triangles, triangle SPS dash and triangle APA dash. It is also a very simple question for you. Let us try to draw the diagram to the corresponding problem. This is x-axis, this is ellipse. X-axis is what? Your major axis. Your major axis along x-axis. So you have the vertices A and A dash. This is A, vertex A, it is another vertex of the ellipse A dash as shown in this figure. And we have two foci S and S dash. These are S and S dash are the foci of the ellipse. So you take any point on this ellipse P. We have to find out the ratios of the areas of triangles, triangle SPS dash and triangle AP A dash. So try to draw the figure. This is AP and this is A dash P. So we have the triangle. That is A dash PA is the triangle. Now again join S dash S to P. This is SP, this is S dash P. So we have two triangles. This is one of the triangle and it is the other triangle. We have to find out the ratio of these two triangles. My dears, for the two triangles, the bases are fixed or not? The bases are fixed. So the only varying is height of the triangle. If your point is fixed, that is also fixed. The height is also fixed for that one. Suppose the coordinates of P are x1 comma y1, clearly the distance from here to here is 1 by 1. That is height. So what is the area of triangle S, P, S dash from the figure itself? Half into base into height. That is half into SS dash. What do you know? 2AE. Distance between two foci is 2AE into Y1 is there. Half into base into height. Half of gets cancelled. AE, Y1. Again, we find the area of triangle. A dash PA. A dash PA. That is half into base. Base is nothing but A dash A. What is the distance from A dash to A? 2A. That is measurement. 2A into height. So this is the common height for both the triangles. So it is Y1. 2 gets cancelled. This is A1. Can you get the ratio? So area of triangle SPS dash by area of triangle A dash PA, that is equals to AE by 1 by A by 1. Y1 by 1 gets cancelled, area also gets cancelled, so the is E. Therefore the ratio is E is to 1. So we have E is to 1. E by 1. We have the ratio E is to 1. Area of the triangle SP S dash is to area of triangle AP A dash is E is to 1. E is always less than 1 for the ellipse. So the ratio is E is to 1. Okay, simple problem. For both the triangles, the height is common, that is y1 set. If it is x1 comma y1, you may take any point in the circumference of your ellipse. Okay. Next question. P is a variable point on the ellipse. What is that? P is any variable point on the ellipse. 9x square plus 16y square is equals to 144 with foci S and S dash. What are the foci of the ellipse? S and S dash are given to you. K is the area of the triangle S S dash P. What is K? K is the area of the triangle S S dash P. Then maximum value of K is what? What is P? P is variable point on the ellipse. S and S dash are fixed. So we have different triangles which are inside of the ellipse. We have to find out the maximum area of the triangle formed by SS dash with P. S and S dash are fixed here. P is the variable point. So we have different triangles. We have to find out the maximum area to the triangle formed by PSS dash. Let us try to draw the rough diagram. And we convert into the standard form first of all. 9x square plus 16y square is equal to 144. We mean x square by 16 plus y square by 9 is equal to 1. This is your standard equation of the ellipse. Let us try to draw that figure here. X-axis, your major axis along x-axis. This is ellipse. X square by 16 plus y square by 9 is equal to 1. This is the point. Now, these are foci S and S dash form a triangle SP S dash. You may have P is here also. Suppose if it is P, this is your triangle. Suppose P may here also. This is S dash P. This is P is moving on the circumference of the ellipse. We have to find out the maximum area of the triangle. So this is fixed, my dears. Base of the triangle is fixed. The distance from S to S dash is always 2a. So for different triangles, you have the different heights. These are all heights. So area maximum depend upon what? Height of the triangle. For all these heights, which one is more? This is the highest height of the values among these heights. Because your point P is at the end of the minor axis, your height is more. So this is your maximum area. By joining end of the minor axis to S and S dash, you get maximum area. Because this height is maximum at this time. This is SS dash. It is base of your triangle that is fixed. So maximum, the area of triangle, the triangle PS dash S has maximum area, at P is equals to your end of the minor axis. This is the triangle PS dash S. It contains maximum area at P is equals to B. So what is the height here? B units, and base is 2A. So area maximum is equals to what, my dears? Area maximum is equals to half into base 2A into height B. So 2 gets cancelled. Your answer is AEB. That means B times of AE. AE means root of A square minus B square. So just to substitute the values of AB here, you get the required answer. What is B? 3 units. Root of a square minus b square. 16 minus 9, that is 7. 3 root 7 is your required answer. So in this problem, the simple logic is when the height of the triangle is maximum, you get the maximum area. This is the simple logic because your base is fixed, SS dash, that is 2AE. So your y1 or y, the height is increasing up to b from 0. So after that it will be again decreasing. These are all heights. So maximum height is obtained from here to here, that is b units. Okay. So what is your required area of the triangle? 3 root 7. Okay. See here, PS P dash is a focal chord of ellipse. 4x square plus 9y square is equal to 36. If SP is equal to 4, then you have to find out SP dash. What is PS P dash? Focal chord of ellipse. What is focal chord? A chord which is passing through focus is called focal chord. One of the segment is given to you. You have to find out the length of the other segment. So this is your ellipse. This is the focal chord. One of the focal chord, that is, it is S, it is your P, and it is your P dash. PS P dash is your focal chord. SP is given to you, that is 4. They are asking SP dash. Not S dash P. If it is S dash P, we can easily write that one as SP plus S dash P is equal to 2A concept. But we are going to find out the other segment. This is one segment, this is another segment. The total length is PP dash. We have the result. What is that? 1 by SP plus 1 by SP dash is equals to 2 by L, where L is semilateral sector. In the point, the focal segments and semilateral sector are always in harmonic progression. This is the concept. 1 by SP plus 1 by SP dash is equal to 2 by L, where PP dash is a focal chord of the ellipse. So you know that 1 by SP, what is SP? 4 units given to you, plus you are going to find out SP dash, that is equals to 2 by L. L means semilateral sector. So to find the semilateral sector, convert into the standard form. X square by 9 plus y square by 4 is equal to 1. What is semilateral sector? B square by A. Length of lateral sector is 2b square by A. 4 by 9 we have. B square by A. A means 3 here. B square is 4. A is 9 by root 9, that is 3. It is nothing but 6 by 4. So this is 3 by 2. Therefore 1 by SP dash is equals to 3 by 2 minus 1 by 4. This is what? 6 minus 1, 5 by 4. Okay. Therefore SP dash is nothing but 5 by 4. 1 by SP plus 1 by SP dash is always 2 by L. 2 by L. L means semilateral sector, that is B square by A. B square is here 4, A is 3, that is 4 by 3. 2 by 4 by 3, this is nothing but 3 by 2. 3 by 2 minus 1 by 4, we have tried, that is 4 LCM. 3 2s are 6 minus 1, that is 5 by 4. It is nothing but 1 plus 1 by 4. So SP dash is nothing but 4 by 5. So 1 by SP plus 1 by SP dash is 2 by L is your crucial formula. Similarly, you have, if it is another focus, S dash, this is the axis, you have one more result. What is that? SP plus S dash P, sum of the focal distances. SP plus S dash P is equals to 2A. This is the another result. From that, from using these two concepts, you can find the distance here. This one also. What is that? S dash P dash also you can find out. you can apply the relation, that is the focal property for P dash also. What is the relation? S dash P dash plus SP is also 2A. S dash P dash plus SP dash is also 2A. Sum of the focal distances of any point on the ellipse is always constant, that is equal to 2A. Already you have SP dash. From that you can calculate S dash P dash also. That is 2A minus SP dash. What is your 2A? That is 6. A square is 9, A is equal to 3. 3 square is 6. 2 3s are 6. 2A minus SP dash, that is 4 by 5. So in this manner we can find S dash P dash also. So just they are asking SP dash, you can find S dash P dash also by using the focal property of the ellipse. Two things you have to remember, my dears. 1 by SP plus 1 by SP dash is 2 by L, where PP dash is a focal part of the ellipse. At the same time, you have to remember SP plus S dash P is equal to 2A. Again, S dash P dash plus SP dash is also 2A. Since P dash is also a point on your ellipse, you can apply the focal property to that one also. Okay? Next one. This is the question. S is focus of an ellipse. See here. S is focus of an ellipse. P is the point on the ellipse. If the maximum and minimum values of SP, we mean what? Focal distances. These are nothing but the focal distances. Are M and N respectively, then the length of the semi-major axis is dash. Among these options, is it arithmetic mean of M and N, geometric mean of M and N, harmonic mean of M and N, AGP of M and N? This is your question. So already we discussed about the focal distance of point on the ellipse. Already we discussed about maximum focal distance and minimum focal distance also. So what is maximum focal distance of point on the ellipse, my dears? Suppose this is your focus S. SA is minimum focal distance, SA dash is maximum focal distance. What is focal distance formula? A plus or minus EX1. For x1, you take x1 as A comma 0, then we have two distances, A plus or minus AE. For x1 comma y1 is A comma 0. The two focal distances are what? A plus AE is one thing, A minus AE is another thing. So this is your point A comma 0, this is AE comma 0, this is minus AE comma 0. So maximum focal distance is what? This is A comma 0, this is what? Minus A comma 0. This is minus A comma 0. Maximum distance is here to here. That is A plus AE. This is the distance, maximum distance, A plus AE. This is the minimum distance. What is that? That is A minus AE. So what is M? What is small m? That you will do. M and N are respectively what? Maximum value. M is equals to A plus AE and N is equals to A minus AE. What is M plus N? M plus N is nothing but 2A. So A is equals to M plus N by 2. What about that one? What is A? Semi-major axis. What is that? A is equals to M plus N by 2. Is it arithmetic mean of M and N or not? This is clearly arithmetic mean of M and N. So, semi-major axis and maximum focal distance and minimum focal distance of point of the ellipse always forms an AP, arithmetic progression. So, M, A, N are always in arithmetic progression. Therefore, your value is arithmetic mean of M and N. Then, the length of the semi-major axis, that is your A. Length of semi-major axis A is arithmetic mean of M and N. M is what? A minus AE. A minus AE is the smallest value. length, maximum value is a plus AE, minimum value is a minus AE from the data itself. Maximum and minimum. M is maximum value, N is your minimum value. So A plus AE is M, A minus AE is your N. Small a is equals to M plus M by 2. Okay. Next one. The eccentricity of this ellipse is what? You can write the standard form. You can easily write the eccentricity, but to give a shortcut form, that is why I am writing the question, this question. The eccentricity of ellipse you have to find out. 9x square plus 25y square and something is there. If it is xy term, if it has xy term, it is not possible to find eccentricity easily. But if there is no xy term in your entire equation, by looking the equation itself, we can write the eccentricity without writing the standard form. Without writing your standard form. So, just by taking the coefficients of x square and y square itself, we can write the eccentricity. So, what are the coefficients of x square and y square? 9 and 25. Which one is more? 25 is more. You just write square root of 25 minus 9 by 25. Large value minus small value by large value by taking under root itself. So, this is a simple shortcut for you. So, that is square root of 16 by 25. It is nothing but 4 by 5. Just like root of a square minus b square by a square. But these are not a square and b square. So, by taking the coefficients of x square and y square itself, we can plot the eccentricity without writing the standard form. We need root of 16 by 25, that is 4 by 5. So, let us check by doing the original method. This is 9x square plus 18x is one thing, and 25y square minus 100y is equals to 116. So take 9 common, 9 into x square plus 2x plus 1 I am writing here, plus 25 into y square minus 4y plus 4 I am writing here, 116. To get the balance I am writing plus 9 and plus 25, 4s are 100. This is 125 plus 100, that is 225. So we have x plus 1 whole square by 25 plus y minus 2 whole square by 9 is equal to 1. By dividing that by 225, we have in this manner. By the equation itself, eccentricity is equals to a square root of a square minus b square by a square, since a greater than b. 25 minus 9 by 25 will mean 4 by 5. So, no need to write all these things here itself. So, no need to convert into the standard form. Suppose if your equation doesn't have xy term, just by looking the coefficients of x square and y square, you can write the eccentricity of the ellipse. Understand? Next one. This is the question to you. What is the question? L is the lattice rectum of ellipse. Yes, L is a lattice rectum of ellipse. This is focal chord perpendicular to the major axis. And triangle SL is an equilateral triangle. That means S is another focus. Always you know that S, L and S are collinear. But they are saying it is equilateral triangle, meaning that that lattice rectum makes equilateral triangle with another focus. That is the sense of humor. Makes an equilateral triangle, then you have to find out the eccentricity of the ellipse. You have to find out the eccentricity of the ellipse. It is very simple for you. Let us try to draw the figure. This is ellipse. It is the lattice rectum that is passing through focus perpendicular to the major axis, and these are L and L dash. This is your another focus. You have the focus here also. This is another focus. This is S is the another focus. You have to form a triangle. This is S, L, L dash. Now your triangle is equilateral triangle. We have to find out the eccentricity of the ellipse. Understand? This is the axis, major axis. The angle is 60 degrees. Here also 60 degrees. It is also 60 degrees. So it is 90 degrees because the lattice rectum always makes angle 90 degrees with the axis. Now what about this one? 30 degrees. This is the length b square by a. This is the length, distance between two foci, that is 2a. From the triangle itself, you can write tan 30 degrees. Tan 30 degrees is b square by a by 2a. So this is nothing but b square by 2a square e. B square by a square is nothing but 1 minus e square by 2e. This is your 1 by root 3. From this equation itself, we can find the eccentricity. 2e is equal to root 3 minus root 3e square. So root 3e square minus 2e plus root 3 equal to 0. So root 3e square minus 3e plus e plus root 3 equal to 0. Root 3e times of e minus root 3. Root 3 times of e minus root 3 plus 1 times of, we are missing here, 2e is equals to root 3 minus root 3 square. This is root 3 square minus 2e, not here. This is root 3 square plus 2e minus root 3 equal to 0. So root 3 square plus 3e minus e minus root 3 equal to 0. So root 3e into e plus root 3 minus 1 into e plus root 3 equal to 0. E plus root 3 never 0 because e is always positive. Therefore, your eccentricity of ellipse is 1 by root 3 itself. So just by solving this equation, we obtain the eccentricity. So only the thing is you have to apply tan theta, that is tan 30. The curve is symmetric about x-axis also. Therefore, this is the angle bisected by the x-axis. The total angle is 60 degrees. Half of the angle is what? 30 degrees. So by taking the tan theta itself, we get tan 30 equal to b square by a by 2a. We have e is equals to 1 by root 3. Okay. A point passing through the origin has its foci at 5, 12 and 24, 7. Its eccentricity is what? This is the question. Suppose this is ellipse chapter. So we take the point as ellipse. You are point passing through the origin. Suppose this is my origin. Actually, it is not the standard form. Your foci are given to you. This is one focus. This is rough diagram. 12, 12 and 24, 7. We have to find out the eccentricity of ellipse. They have mentioned the point because this chapter is ellipse. We are taking the point as rough focus. So we have to use two things. This is s dash s. The distance between the two foci is 2a. Also you have to apply the focal distance. Sp plus s dash p, that is also 2a. Once if you have 2a and 2a, you can write eccentricity. Now what is sh dash, my dears? This is nothing but square root of 24 minus 5 whole square plus 7 minus 12 whole square. This is 19 square plus minus 5 square or 5 square. This is nothing but 25 plus 19 19s. 361 plus 25 is also there. 683, 386. The entire total value is 386. Root 386. This is SS dash, that is 2a. Again, we have to find out SP. SP is nothing but root of 24 square plus 7 square. That is nothing but 25 square. Square root of 25 square means 25. S dash P. That is nothing but square root of 5 square plus 12 square. That is 144 plus 25, 169. That is nothing but 13. SP plus S dash P. What is that? 38. That is 38 is there. So 2A is equals to 38. Therefore, your eccentricity E is equals to 2A by 2A. What is that? Root of 386 by 38. In this manner, we can easily calculate the eccentricity of the given data itself. We are using here the two concepts. One is the distance between two foci and another one is focal property of the ellipse. That is SP plus S dash P is equals to 2A. Thank you very much.